So this is the first of two examples that we're going to do for superposition. So notice here that we have a dependent source in the circuit. And if we remember the steps for doing superposition, we can only turn off independent source. And so when we have a dependent source in the circuit, we just have to let it sit as or be as it is. We're not going to turn it off. We're just going to live with it each time we turn off an independent source. So there are two sources in this circuit. We have the 20 volt source and we have the 7 amp source. So we will have two parts to the voltage V out that we are solving for, VO here across the 40 ohm resistor. And we will let 4Ix sit in the circuit as each time. I forgot to label where Ix is. Here is Ix, the current that controls that dependent source. Okay, so let's see how we handle this. So let's start with the 20 volt source on. So we'll have the 20 volt. We'll have the 10 ohm resistor. We'll have an open circuit where the 7 amp source is. We'll have the 40 ohm resistor. We'll have the 4Ix dependent source. Here's 20 volts. Oops, and I turned this around. I'm sorry. This should be the opposite way, minus and plus down there. So this is 20 volts. This is 10 ohms. This is Ix1 because we're dealing with the first iteration of the circuit that controls the Ix1 up there. And then we have the 40 ohm resistor here, and we have VO1, the first part of the voltage VO, that's a function of the 20 volt source. Okay, so remember when we get to this point, we can solve for that voltage VO1 using any method that we like. I'm going to do mesh analysis. So I've got a mesh current here, I1, and a mesh current here, I2. Okay, and so we know that I1 is equal to 4Ix1. Okay, so this dependent source here is a dependent current source. I1 flows in the same direction. We can also relate Ix1, the current that controls that source, to the mesh current. So I2 flows in the direction of I1 or Ix1, and I1 flows against. And so we have that Ix1 is equal to I2 minus I1. And then ultimately what we're solving for is VO1, and by Ohm's law that's going to be 40 times I2. Okay, just like when we used a mesh analysis before, we don't have to write a mesh equation if we already know what the mesh current is. We know that I1 is equal to 4 times Ix1, so we don't need mesh 1, at least not to find the mesh currents now. So mesh 2, starting with that 20 volt source, we're going to subtract 20, coming around to the 10 ohm resistor, minus 10 times I2 minus I1, coming around to the 40 ohm resistor, minus 40 times I2 is equal to 0. Okay, we're going to simplify this this circuit here, or this equation here. So we're going to have 10 I1 minus 40 I2 is equal to 20. Excuse me, not 40, this should be 50. 50 because we have minus 10 and minus 40. So minus 50 I2 is equal to 20. So there's one equation. All right, then our second equation is going to come from the things that we know here. All right, so if we take that I1 is equal to 4 times Ix1, we can also write that I1 is equal to 4 times I2 minus I1. All right, and so when all is said and done and we simplify this equation, we'll have 5i1 minus 4i2 is equal to 0. So now we have two equations, two unknowns. And when we solve those, we have that I1 is equal to minus 0.48 amps, and I2 is equal to minus 0.38 amps. And then we can take I2 here, and take our mesh currents. We can take I2 and put it into that VO1 equation, and we'll have that VO1 is equal to 40 times that minus 0.38, or VO1 is equal to minus 19.05 volts. Okay, so that's the first one. Now we need to go with the 7 amp source being on. Okay, and with the 7 amp source on and the 20 volt source being off, we're going to have a short circuit where the 20 volt source was. We have the 10 ohm resistor. We have the 7 amp source. We have the 40 ohm resistor. And then we have the dependent source. So this is for IX. Here is IX2. So this is for IX2. This is the 10 ohm resistor. This is the 7 amp source. And the 40 ohm resistor. And VO2, the second part of the voltage V0, that's a function of the 7 amp source. Okay, and I did this using nodal analysis. But again, you can solve for VO2 using any method that you like. So I see that there are a whole bunch of connections here at this node relative to this node. So we really only have 2 nodes in the circuit. So I'm going to identify these 2 nodes here and here. I'm going to make this one my reference node, and I'm going to call this one V1. Okay. So note what VO2 is equal to. So let's start off with some things that we know. So we know that what we're solving for, VO2, is just V1 minus 0. So we have plus V1 minus the reference node. Hold on, please. Okay, sorry. So, so we know that. What else do we know? Well, we have IX sitting here. We're going to IX2 at least, so we need to write a relationship for it. So IX2 is equal to 0 minus V1 over 10. Okay, so those are the 2 things we know for nodal analysis. So now we're going to write our node 1 equation there for V1. So the current flowing to the left is going to be V1 minus 0 over 10. The current flowing down is going to be minus 7, opposite the current source. And then we have 2 currents here. So we've got this kind of elongated node here, but we have this current here and this current here. So the current flowing down on the far side there is going to be V1 over 40. And then the current flowing up is going to be minus 4IX2. Minus because the current that we want is the current flowing in this direction, and the current source flows in the opposite direction. Okay, so if we substitute in ix2 here into this expression here, we will have v1 over 10 plus minus 7 plus v1 over 40. We're going to have a minus 4 times minus v1. So this is going to be plus 4 times v1 over 10. And that's going to sum to 0. So now we're going to solve for v1. And when we do that, and did I write the whole equation down? Yeah, I did. So this equation will simplify to v1 times 0.525 is equal to 7. And so v1 is going to equal 13.33 volts, or VO2 is going to equal 13.33 volts as well. So now our total voltage VO is equal to VO1 plus VO2, or VO is equal to minus 5.72. All right, so that is our first example. So when we have a dependent source in our circuit and we're doing superposition, we just use it each time. We don't turn it off, we just use it as it is. Okay, so we used it in the first one, we used it in the second one. Okay, let's do one more. So all right, so we have 45 volts and 10 volts and 8 amps. And we have 5 ohms, 10 ohms, 40 ohms, 15 ohms, and 30 ohms. And we're going to solve for this voltage here, VA. All right. So we have 3 independent sources in the circuit. We're going to have 3 sub-circuits, 3 parts to that voltage VA. All right. So let's see. So I'm going to start with the 45 volt source on. All right, so we'll have the 45 volt source. Have all our resistors. We'll have a short circuit where the 10 volt source is. We'll have an open circuit where the current source is. So this is what our circuit's going to look like. All right, and we're going to solve for VA1, the first part of the voltage VA that's a function of just the 45 volt source. Now this would be not a bad one to do simplification and expansion if you want a little practice. You could simplify this pretty quickly, but I did mesh analysis since that's what I find historically students like a little better. So I did mesh analysis. So let's label these. Here's I1 and this is I2. And we know that VA1 is equal to minus 30 times I2, minus because of the passive sign convention. So our mesh 1 equation, starting with the voltage source, is going to be 45 minus 5 times I1 minus 40 times I1 minus I2 minus 15 I1 is equal to 0. And then mesh 2 is going to be, I'm starting with the 40 ohm resistor, so minus 40 times I2 minus I1 minus 10 times I2 minus 30 times I2 is equal to 0. So my equations are going to simplify to, the first one is, mesh 1 is going to simplify to minus 60 I1 plus 40 I2 is equal to minus 45. And mesh 2 will simplify to 40 I1 plus 80 I2, excuse me, minus 80 I2. Minus 80 I2 is equal to 0. And so when we solve for these, we'll get that I1 is equal to 1.125 amps, and I2 is equal to 0.5625 amps, which means that VA1 is equal to minus 16.88 volts when we put it into that Ohm's law equation there. Okay, so let's do our next one. It's going to be 10 volts. Yes, 10 volts on. So with the 10 volt source being on and the 45 volt source is now off, so we'll have a short circuit there. We'll have our resistors here. So we have 10 volts, we have 10 ohms, we have 30 ohms, we have 40 ohms, we have 5 ohms, and we have 15 ohms. And we're going to be solving now for VO2, the second, or VA2, excuse me. VA2, the second part of the voltage VA, that's a function of just the 10 volt source. Remember that current source is still, so we have a current source here and we've opened that up, so it's not there. It's off. Okay, now for this particular circuit, I am going to do some simplification. So if I look here to the left of this part of the circuit, I'm going to have the 5 and the 15 ohm resistor connected in series here at this point. And that 20 ohm series combination will then be in parallel with the 40 ohm combination, with the 40 ohm resistor. So I can draw kind of what this circuit is going to look like with just that one simplification, or really the two simplifications in one step. So this resistor here is now going to be 20 in parallel with 40, which is going to be 13.33 ohms. This is still 10 ohms here. This is still 30 ohms here. This is still VA2, and this is 10 volts. But now we've got a nice simple voltage divider by making, again, that one set of series and then parallel combination of those three resistors. Okay, so now by voltage division, I can say that VA2 is equal to 10 multiplied by the resistor I want to know about, which is 30, divided by the series combination here, which is going to be 53.33. All right, but, and I'm going to erase this for a second and give myself a little more room. But the passive sign convention isn't holding. So the current's going to flow from minus to plus through the source, which means it's going to flow from minus to plus through the resistor. The passive sign convention is not going to hold, so I need to put a negative sign out in front to adjust the passive sign convention. And so now I'll get that VA2 is equal to minus 5.625 volts. Now, if you would much rather work this using mesh analysis, by all means do that. If you like nodal analysis, by all means do that. There is no one right answer for this. You get your choice on these subcircuits, how you solve them. Okay, but this was pretty straightforward. All right, so the last source that needs to be on is that current source. It hasn't been on yet. Okay, so we're going to have short circuits. So we're going to have 8 amps on. So we're going to have short circuits where the 2 voltage sources are. So this is 8 amps. This is 30 ohms. This is 15 ohms. This is 5 ohms. This is 10 ohms. This is 40 ohms. Actually, I'm going to write this 40 ohms on the other side. 40 ohms. And here is now VA3, the third part of the voltage VA that's a function of just that 8 amp source. Okay? And again, you can do whatever method you like for this. I am going to do a mesh analysis here to solve for VA3. So I've got 3 mesh currents here. Here is I1, I2, and I3. We know that I3 is equal to -8 amps because the mesh current goes opposite to the current source. We also can write that VA3 by Ohm's law is equal to 30 multiplied by the net current that flows from plus to minus. That's this current, which is going to be I3 minus I2. Okay, so we need mesh 1 and mesh 2 equations. So mesh 1 is going to be -5 times I1 minus 40 times I1 minus I2 minus 15 times I1 minus I3. That sums to 0. Mesh 2, starting with the 40 ohm resistor, minus 40 times I2 minus I1 minus 10 times I2 minus 30 times I2 minus I3 is equal to 0. Okay, let's simplify these real quick. So we'll have I1, minus 55 I1, no, minus 60 I1, plus 40 I2 is equal to, so I3 is equal to -8. So we're going to have this equal to 120. Yeah. And then our mesh 2 equation is going to be 40 I1 minus 80 I2 is equal to 240. So when we solve this, we'll get that I1 is equal to -6, and I2 is also equal to -6. All right, and so we'll have that VA3 is equal to -60 when all is said and done, volts. And so now VA is equal to VA1 plus VA2 plus VA3. So this is equal to, VA1 was -16.88. VA2 was minus 5.625, and VA3 is minus 60. And so VA is equal to minus 82.51 volts. Okay, and that's how you're going to work these circuits every single time. So what I would encourage you to do if you want more examples is to go back through and look at the examples that we used on nodal analysis, mesh analysis, and try your hand at superposition on those. You already know what the answers are. And so if you need extra practice, that's a good way to go.